Here is a nice problem that was suggested by viewer. Here is the following information. We have n as a natural number. So we have these both conditions, n minus number 1 and 2n minus number 1 are a perfect square. Okay? So the question is, we are going to determine the appropriate values of n in order to have both statements as a perfect square. Okay? In fact, this is very nice and interesting problem to work on. So now let's go through this one. So we are saying n minus number 1 as a perfect square, which is x squared. The other one, 2n minus number 1 equals y squared. Both are perfect square. Okay? So the easiest way to solve this one, we are going to get rid of n. Okay? Let's multiply the first equation by number 2 and make the difference of two equations. Okay? So here is first one, I will get 2n minus number 2 equals 2 times x squared. The second one, I get the same thing, 2n minus number 1 equals y squared. Okay? So I'm going to make this equation minus this equation. So I get 2n cancelled out. I will be left with minus number 1 minus number 2, which is number 1, equals y squared minus 2x squared. Okay? In fact, this is very nice expression. So I have undo this equation. So which form this equation is taking? This is called Pell's equation. Pell's equation is written on this form: y squared minus dx squared equals number 1. So in this case, d equals number 2 here. Okay? So as we know, to find the solution for this equation, first of all, we are going to find the first obvious solution for this equation, then apply the recursion on this one to find the copies of other solutions for this equation. Okay? So it's very simple here to find the obvious solutions. I get here xy, x0 equals 2 and y0 equals number 3. Okay? Of course, we have plus or minus because we have the square here. So as we are replacing x with number 2 here, you get minus 8. If you replace y with number 3, you get 9. 9 minus 8 is given as number 1. Okay? This is the first solution. So we are going to apply the recursion on this one, then we find other solutions. Okay? So first of all, by factoring out this one, I get here y minus square root of 2 x factor y plus square root of 2x equals number 1. Okay? I'm not going to provide the proof for this one, so we may have a different values for that. So we'll have, by taking this one, taking y plus number. So to find the solution for this one, always the solution for this one is going to be written on this form. Okay? So y0 plus square root of 2 x 0. Okay? By replacing y0 with number 3, I get here 3 plus 2 square root of 2. Okay? So it doesn't matter if you put the plus or minus. Let's take the positive solutions. Okay? So in order to find the second solution, we are going to make the recursion. Okay? By multiplying the same number by another number. This one, the exponent number 1 here. For the second solution, I get y plus square root of 2x equals the same number, which is 3 plus 2 square root of 2 square. Okay? So this one is given as a first solution, which is x0 equals 2 and y0 equals 3, as we have here. Okay? So for the second solution, by simplifying this one out, so I get here 9 plus 8, which is 17, plus 4 is multiplied by 3, which is 12, square root of 2. Here is a second solution, which is x1 equals 17 and y1 equals 12. Don't look for the negative or positive solutions, because we don't care about the x, we don't care about the positive or negative solutions, because we have x squared anyway here. So because we are looking for n. So whatever the sign of x, as we have as x squared, everything turns positive. Okay. So now to find the third solutions, just multiplying this one by this one. Okay. So I get y plus square root of 2x as a solution. We have 3 plus 2 square root of 2 square is multiplied by 3 plus 2 square root of 2. Okay. So I will have the same number which we have here, which is 17 plus 12 square root of 2. It will be multiplied by 3 plus 2 square root of 2. Okay. So by simplifying out this one, you get 17 is multiplied by 3, which is 51, plus this term is multiplied by this term. So square root of 2, you get cancelled out. Square root of 2, it will be cancelled out because we have the same copy of square root of 2. Square root of 2 is multiplied by square root of 2 is given as 2. 2 is multiplied by 2, which is 4. 4 is multiplied by 12, which is 48. 48 plus 51, which is 99. Okay. So you get 99 here, plus another number which is related to the square root of 2, which means I get here, this one is multiplied by this one, which is 2 is multiplied by 17, which is 34. Okay. Then 34, I will have 3 is multiplied by 12, which is 36. 36 plus 34, which is 70, plus 70 square root of 2. Now I have the second, now you have a third solution. I get x, this is y1, this is x1. Okay, the same thing here. This is x1, you get 70 here, and x3, you get 70 here, and y3 equals 99. Okay. So what's the general formula for the other solutions? So the general formula, which is y plus square root of 2x, which is this one, 3 plus or minus 3, 2 is multiplied by 2 to the 2n plus number 1, because this written is going to take us to this form. Okay. So as you find the fourth solutions, we are going to multiply the previous expression by another one. Okay, and so on and so forth. So at the end you will have this expression. So doesn't matter plus or minus, because always you get this is odd, the exponent is odd, this one, this minus, it can go inside, and you will have the negative solutions. Okay. For this case, be careful, this n is not the same as we have, so we are going to change this one to m to avoid mixing this n with this one. So I'm changing to m here. Okay. What is the m? Is a some integers. Okay. So if you want to find other solutions, just replace m with the next value. Okay. So we'll have many infinity solutions. So the solutions for this one never gonna finish. So now remember, we just determined the solutions in terms of x and y, but we need n. So we are going to take these values that we found and replace it into the previous equations to find n. Okay, let's write this one here. So for the first solution, you get n equals x squared plus number 1. So for the first solution, you get x0 here and 0, for example. Okay, so we get x0, which is 4 plus 1, which is 5. So we found the first solution, and 0 equals 5. If you replace 5 here, you get 5 minus 1, which is 4. 4 is a perfect square. Also replacing the same value of n, which is 2 is multiplied by 5, which is 10. 10 minus 1 is given as 9. 9 is a perfect square also. Okay, So let's go to the another value, which is n1. n1 will be replaced with x1 square plus number 1, which is replacing x1, which is 12 square, which is 144, plus number 1, which is 145. So this is the value of n1. Let's square this one like this. So if you take in this value and replace it in both equations, it will satisfy this equation. Let's take the third solution that we have here. So we have n2 is giving us x2 square plus number 1, x2 square, which is 70 square plus number 1 is giving us 4901. This is the abyss solutions that we found. So we can find other solutions just to replace m with any value. So we will have infinity many solutions. Just replacing m is going to give us a new solution. Okay, so I have ended this video. If you have any question regarding this equation, by the way, don't forget to support us with your like and subscribe. Thank you for watching. I will see you next video. Bye.